Okay, today's lesson is 5.3, and the objective today is to solve linear systems of equations by the method of elimination, or this computer program calls this method addition. And the numbers that I'll be doing are 1, 3, 5, 7, 8, 9, and 10. Okay, we're going to solve these systems of equations today by the addition or elimination method. And the reason the book calls it the addition method is because we're going to add these two linear equations together. Now, the reason I call it the elimination method, and other books do also, is because the goal of adding these two systems together is to eliminate a variable so that you only have one variable to figure out at a time. So if I add negative 2x plus negative 6x, I'll get negative 8x. And then if I add positive y plus negative y, I'm going to get 0. That eliminates the y values. Then if I add negative 8 plus negative 8, I'm going to get negative 16. So now I've eliminated a variable, and I can easily solve this equation, negative 8x equals negative 16. So I'll just divide both sides by negative 8. When I divide both sides by negative 8, the answer is x equals 2. Now I'll take what x is equal to and substitute it into either of my original equations, and then I can figure out what y is. It looks like to me the first equation is easier to substitute because the y is positive in that equation. So I'm going to substitute my 2 in place of x in the first equation. So in place of the x, I've put 2, so I've got negative 2 times 2 plus y equals negative 8. And now I'll simplify. Negative 2 times 2 is negative 4, so negative 4 plus y equals negative 8. Now I'll move my like terms to the same side of the equation. So y equals negative 8 plus 4, and then I'll simplify and y equals negative 4. So the solution to this system is 2, negative 4. Now remember that you can always check the solutions to systems of equation by just substituting those numbers in place of x and y in the original equations. It should make both equations true. Negative 2 times 2 plus negative 4 is negative 8, so it works in the first equation. In the second equation, negative 6 times 2 is negative 12, minus negative 4 is also negative 8, so it makes the second equation true. That means our solution is correct. Don't forget to do that on a test so that you don't miss the problem. You should never miss these because you can check your solutions. Now on number 3, there's a little bit of a problem because if I add these two linear equations together, there's not going to be a variable that's eliminated because 3x plus negative 8x is not going to eliminate the x's, and 1y plus negative 2y is not going to eliminate the y's. So what I need to do in this one is actually multiply one of my equations by a number that will help me eliminate a variable. Now I know that 2y plus negative 2y will equal 0. So I want to multiply my first equation by the number 2. Now remember to multiply everything by 2. So the 3x gets multiplied by 2, the y, and the 9. That's because that's the only way to keep this equation equal to its original equation, because if I reduce after I multiply by 2, it's going to come right back to 3x plus y equals 9. So after I multiply everything by 2, I've got 6x plus 2y equals 18. And now I'll add the second equation to that. So adding my x's together, I get negative 2x. Adding my y's together, those are eliminated. 2y plus negative 2y is 0. And 18 plus negative 28 is negative 10. Now I'll divide by negative 2, and x will be 5. Now to figure out what y is, I just need to substitute 5 in place of x in either equation and solve for y. The easiest equation to use looks like the first one because again those y's are positive. So substituting 5 in place of x, I've got 3 times 5 plus y equals 9. 3 times 5 is 15 plus y equals 9. Now I'll move my like terms together. So y is equal to 6. So the solution to this system of equation, there's one point where these two lines cross, and it's at 5, 6. And remember, I can substitute that point in. 3 times 5, well, it's actually 5 negative 6. I was getting ready to check that. So that made me know that that wasn't right. 3 times 5 is 15, plus negative 6 is 9. And then negative 8 times 5 is negative 40, and then negative 2 times negative 6 is positive 12, so negative 40 plus positive 12 is negative 28. So 5 negative 6 makes both of these true. Okay, number 5 is very similar to number 3, so I know if I add those two together, there's no variable that's going to be eliminated. But I also know that negative 5x plus 5x is going to be 0. So I'm going to multiply my first equation by negative 5. So after multiplying everything by negative 5, I've got negative 5x plus negative 25y equals negative 20. Now I'm going to add my second equation to that. This time my x's are eliminated, and negative 25y plus 6y is negative 19y. Negative 20 plus negative 18 is negative 38. Then I'll divide by negative 19 to get my y value. So my y value is equal to 2. Now I'll substitute to find x. Looks like the first equation is going to be the easiest. So when I put 2 in place of y, I have x plus 5 times 2 equals 4. 5 times 2 is 10, so x plus 10 equals 4. Move my like terms together, so x equals 4 plus negative 10. So x is equal to negative 6. So the solution to this system of equations is negative 6, 2. Okay, on number 7, all of my variables are lined up, but I can tell if I add those together that it's not going to be eliminated. So I need one of my variables to be negative, and I either need the x's to be negative 8 or the y's to be negative 4. So I'm going to multiply my top equation by negative 2. So after multiplying by negative 2, I've got negative 8x plus negative 4y equals negative 10. Now I'll add my second equation. Now what happens when I add these two equations, both the x's and the y's are eliminated. So I've got 0 on one side equals negative 10 on the other side, because negative 10 plus 0 is negative 10. Now we know that that's a false statement. 0 can never equal negative 10. So this is no solution. These lines must be parallel. Okay, on number 8, we can see that the x's and y's are lined up, but neither one of those are going to be eliminated. So I'm going to multiply my first equation by 3, and that will make my x's negative 6 and my y's positive 3. So I've got negative 6x plus 3y equals 3. Now I'll add my second equation. Now in this case, everything gets eliminated. The x's, the y's, and the 3 minus 3 is also 0. So we've got 0 equals 0, and that's a true statement. And so that means there are infinitely many solutions. This is these are identical lines, and they're land on top of each other. So that means there are infinitely many solutions because these lines cross all the time. Okay, on number 9 it says solve the system by either the addition method or the elimination method or the substitution method. I personally like the elimination method. My x's and y's are lined up nicely, So I'm going to go ahead and multiply my first equation by -1 because that will eliminate my y variable. So after I multiply my first equation by -1, I've got -1x plus -4y equals -1. Now I'll add the second equation. So when I added the second equation, the y's were eliminated, and I have 3x equals -9 because -1x plus 4x is 3x, and then -1 plus -8 is -9. Then I divided both sides by 3, and I have x equals -3. Now I'll substitute -3 in my first equation and solve for y. Substituting -3 in place of x, I have -3 plus 4y equals 1. Now I'll move my like terms together. So I moved -3 over to the other side and made it plus 3. Then I divided everything by 4, so y equals 1. So the solution to this system is -3, 1. Okay, the last example that I'll do is number 10. Again, we can solve the system by either addition or substitution. And again, I'm going to choose substitution because it looks like my 4y's would eliminate very nicely without even having to multiply. One thing I do need to do is to move my 5x's over to the other side to line those up. So I'm going to do that first. So I move my 5x's over, and that's -5x plus 4y equals 16. Then I'm going to add the second equation to that. So the y's are eliminated, and I have -1x equals 0. Now be careful here. This one can be solved. Now if it had 0x equals -1, then that one could not be solved because you can't divide by 0. But this one can be solved. We want to divide by -1, and the answer is x equals 0. Then we'll substitute that 0 in place of x and figure out y. So substituting 0 into my first equation for x, I've got 4y equals 5 times 0 plus 16. 5 times 0 is 0, and 0 plus 16 will be 16. Then I'll divide everything by 4, and so y equals 4. So the solution to this system is 0, 4.